Welcome, SHSATers. How's everybody out there doing? Greg from Greg's Tutoring NYC. What is up? What is up? What is up? How y'all doing? So again, we're on I think I'm on part 6. Not exactly sure if I remember, of the cover-to-cover review. We started with the math section, so we're on Form A, doing some of the questions there. I'm just going to jump right in here. It's the same old. This is from the 2021-2022 handbook. We have a car traveling 55 miles per hour. Let me get my pen set up here. Car is traveling 55 miles per hour, and 1 mile is 5,280 feet. You guys should all have this memorized, even if they didn't give that to you. Which of the following calculations gives the car's speed in feet per seconds? Interesting. So let's see, I'm going to use my space up here. 55 miles per hour. So that means it's 55 miles. Here, you know what? Let me do that over because I want to write that smaller. So I have enough space to do it in. Please like and subscribe. Catch this in the replay, you can also like and subscribe. Catching this replay, you can stop, try to solve it yourself, and then see if I get the same answer. And a lot of questions, I'm actually going to try to use an alternate solution when possible, and talk about other things beyond just solving the problem. Let's see, I'm going to use MI for miles. The problem with using M is it could also mean meters or minutes. In fact, I'm going to put MIL then, just so it's quicker, and then I'm clear what's what. When there's 2 units, that might have the same thing. So it's 55 miles per 1 hour. Now let me write the word hour. Come on, bro. Okay, and at some point on the right-hand side, let me just make sure this is on your screen. Yes, it's on your screen. Let me make sure the stream is live. It's saying the stream is having problems. By the way, I'm doing this while you guys are in school, so I actually don't expect anybody to join the chat in here, but let's see how it goes. Maybe a parent or a straggler might come in here, or a troll. Although you trolls come into the streams anyway. All right, so at some point we want to end up with feet per second somehow over here. So you can put that on the side there if you want. That's a bad S. Let me just make it 1S. But you know what? I'm going to get rid of that 1 because we're not trying to shoot for 1. We're trying to shoot for whatever the conversion turns out to be. Okay, we also note that they give us this here again. Okay, so it seems to me, let's convert the miles to feet first, and then second, where we're about the hours to seconds. We can do the hours to second first, but I just want to get rid of that equation. So what we do is when we cancel numerator denominators, we're normally talking about doing that to simplify something. We want to perhaps do that if we can. The second thing we want to do is we can also cancel out units. Okay, so if I put the 1 mile at the bottom here, that means what we're going to attempt to do is cancel this mile with that mile. The words, the actual words, we're going to cancel numbers and we're going to cancel units. Okay? That means 1 mile was the 5280. And that's 5,280 feet, which is what we want to end up with at the top because we know that from over here. So let's write it in, just so we're behaving with our conversions. Okay, and we can extend that out too if we want to. Okay, now we seem to be okay with the top because the top is 55 times 5280 feet. That's the only thing left. We got rid of the miles. So now we have to work on the hour part, okay? So let me change the color of that just so it's clear what we're doing. So what it means is we want the hour on top here, because what we eventually want to do is cancel out the 2 hours. Well, we know 1 hour is 60 minutes. This tablet is pitiful. It's not the tablet, actually, it's the computer. Let me erase that bottom. We're wasting so much time in every session doing this. By the way, this is okay on Zoom and so on. It's just the whole combination of getting this working on YouTube is so awkward and inconvenient. And I've tried a whole bunch of different ways to do it. I think I'm going to need to change the sourcing computer that does this. Okay, so this is minutes. So I'm just going to put N for minutes. Minute. Okay, this means we can cancel out the hour here with the hour there. Okay, so now we're left with feet over minutes, and then it basically means that we need to now do 1 minute. So I'm going to use N for minute over 60 seconds. Okay, so the ends here cancel as well, and what we're left with is the 55 times the 5280, and the bottom is the 60 times the 60. So normally when there's a question like this, and we're left with the top only has feet and the bottom has seconds, so we've done the conversions. So we need to look for the one that matches that. Now, often they don't have one that actually matches that completely. Okay. Okay. In our case, it would be F though, because they actually did the 60 times the 60. Sometimes on questions like this, they give answers that are not exactly what you would end up with, but might be just before it. So in this case, they actually multiplied it out. They didn't multiply the numerator out. They kept it as 55 times 5, 20, 80, and the denominator is they did the multiplication out of, right? So the answer there would be F. Okay, this is what's a classic age problem. It's on many standardized exams. It's also part of a kind of an integral part of your grade 7 kind of algebra discussions. Today, Tien's age is a quarter of Jordan's age. So Tien is, and is equal, 1/4 of Jordan. So that's the same as J over 4. Okay, so we're done with that translation of the English to the math. In 2 years, Tien's age will be 1/3 of Jordan's age. So in 2 years, so Tien plus 2. And when you see something like this, it means both persons' information needs to be extended. So it will be Tien plus 2 is, right, will be is the same as the is part. So that's their equal. And then what I like to do is put parentheses around the other part. And they're not required in all cases, so we have to see if that's true here. So that's going to be Jordan plus 2, because it's also 2 years for Jordan, right? A lot of kids forget to leave this part out. It's both of them is going to be 2 more. Okay, and close the paren. So this line here is kind of a classic line, the way to start off with when they start giving this kind of discussion. Okay, and now, so Tien in 2 years will be 1/3 of Jordan's age. So then that's over 3. Okay, that's a 3. Please be a 3. Okay, so now what we can do is replace T with J over 4 because that's what we have here from this. Okay, so we're going to take T out and replace it with J over 4. And the reason we did that is now we have an equation that only involves one variable, J. We've gotten rid of T for now. Okay? Plus, the other thing is it's asking how old is Jordan today. Okay? We could have solved for T and then plugged it back in and got Jordan's age, right? We could have done that. So now what we have is we have one of these expressions here, and both sides has the denominator. So what I like to do in cases like this is get a common denominator out of the two of them. And 12 would be it. Okay? So it means I can multiply both sides of this equation by 12 every term. Okay? So if I multiply the J over 4 by 12, I will get 3J. Yeah, that's sloppy. Wait a second. Right? 12 times J over 4. The 4 cancels into 12 and gives 3. So we're going to get 3J. Okay, there's 2 terms here. There's the J and there's the 2. So 12 times 2 is 24. Right? I'm multiplying everything, every term in both sides of the equation by 12. So that's done with the left-hand side. And if I do 12 over here, right? 3 goes into 3 once, the 3 goes into here 4 times. And then I have j plus 2 in a parenthesis times 4, right? So that means I'm going to get 4j plus 8. Okay, all we're doing at this point is solving the algebra. Okay, we had 2 fractions, and the simplest way to address that, instead of just getting all weird math, is get rid of the denominators completely. So we multiplied everything by 12. Okay, so now I have 3j plus 24 equals 4j plus 8. I can get rid of this 3j here, subtract 3j on both sides. This 4 goes away to be 1j. So all we're left with now is j. Okay, and then I can subtract 8 from both sides, so we get rid of that, right? And if I get rid of it here, this becomes 16. And that's it, I'm done. J equals 16. Okay, and because we started out with this here, then it is the age today. So then the answer would be 16. Okay, on test day, what you should do is take it and feed it back into your equation, right? So if j over 4, 16 over 4 is 4, right? That would work. And then we can plug it into the other. We can also feed it back into English. Today, Tien's age is a quarter of Jordan's age, right? So then Tien would be 4, okay? In 2 years, when Tien is 6, that will be 1/3 of Jordan's age. Well, Jordan will be 18 by then, and 1/3 of that is 6. So it works out. Feed it back in. Do it slow to make sure you're not making a goof up error. Okay, how many positive even factors of 48 are greater than 24 and less than 48? So this is just an annoying question, because if we actually go through and do the factors of 48, so we have 1 and 48 are 2 of the factors. Then we're going to have 2 and 24. Then we're going to have 3 and 8. Some of you guys don't know how to do all your factoring like this. Anyway, we're going to have 3 and 8. I mean 3 and 16, sorry. A lot of you guys don't know that 3 and 16 are factor pairs of 48. In this number 48 and this 3 and 16, it comes up an awful lot in standardized tests. Okay, 4 and 12. And again, this means you guys need to know your multiplication tables like fluidly, like in your sleep. And then there's 6 and 8. Okay, so this question is simple on the surface, but it means you kind of can't leave one of these out. Okay, so now it asked, how many positive even factors? So these are all positive, they're all even. So a 48, except for one, right? So we're not going to include that, are greater than 24 and less than 48. So that's not greater, 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 that's not greater. 24 is not greater than 24. So we're left with 48 and less than 48. Whoops, looks like we got none left. So it looks like the answer is E. So be careful with this. We kind of really could have solved this straight up without having to have listed these, because there's nothing left. It kind of should be obvious to you. But again, it's a tricky question, and that's the nature of these kind of things. All right. Okay, so the next one is mixed fraction addition. Yay. Right, there's always a couple of ways to do this. This is the way I'll do it, if I can get the page to center right. Come on. All right, so 89 is, I would add up the whole numbers. So I'm going to get 2 plus 3 is 5, plus 5 is 10, plus that. So I'm going to get 14 for the whole numbers. And if you notice, I did the 5 and then I got the 5. What I'm also going to do is double check that, just to make sure it really is 14. So I get 5 plus 4 is 9, plus 3 is 12, plus 2. So I did it backwards. I get 14 again. So I notice now I have to add up the fractions, and I need a common denominator. So the common denominator is going to be 10. So I have to write those out. This is already a 10, but I'm going to put it down because I'm going to add all these up. So I kind of want it there, just so I don't forget that it was a fraction to be added. So those will be our 4 fractions that need to have additions done to them. So 1/5, I'm multiplying times 2, so I'm going to get 2 above. 1/5 is 2/10. Okay. 3/10, it's 3/10. There's no conversion that needs to happen. Okay. 2/5, I'm going to do it times 2, so I'm going to get 4 there. And 1/2 is times 5, so I'm going to get 5 here. So just like I counted the other thing backwards, what I'm actually going to do is stop for 1 second and make sure I did them all correct. And since I'm at the half, I'll just start there and work backwards again. So times 5, cool, times 2 is 4, times nothing, and then times 2 is 2. So I get 3 plus 4 is 5. I also get 14/10. And if you notice, the fractions are the same tenths as the whole number part was. Right? We had 2, so 1/5 gives us a 2 numerator. 3/10 gives us a 3 numerator. 2/5 gives us a 4 numerator, and 1/2 gives us a 5 numerator. Okay, and this is equal to 1 and 4/10. 1 and 4/10. So all we need to do now is take the 14 and add it to this. So we get 15 and 4/10, and 4/10 is equal to 2/5. So our answer would be D. Okay, easy peasy. This is like a 30-second problem. Bing, bang, boom. By the way, the previous question should have also been a bing, bang, boom question. Those are 2 questions. This one and the previous one are 2 questions. you want to use to save time because they're that simple. You could have lined these up going up and down. You could have written 2 1/5 and underneath the 3 3/10. You could have done it that way. I just use what's available on the page. Everybody thinks different. So this is just advice to do it whatever way you want. All right. Obviously, once you got the 14 with the whole numbers, it should be clear to you that even though you may not have known that 1/5 plus 3/10 plus 2/5 plus a half was 1 4/10, you should have known it wasn't 7/20. Would rule this out, okay? And even though you didn't know a fifth plus a 3/10 plus 2/5 and a half is 1 4/10, you should have known it wasn't 2/5, because in fact 2/5 is one of the numbers inside of it that you're adding. So you know the answer can be B as well. All right. C gets iffy because C is basically 3 1/2, which is pretty close to what the answer was. So you kind of can't guess C versus D. They're too close. But at least you have a way to double check this. First of all, you have a way to double check is actually go and do it again. But you can certainly rule out A and B as kind of a little safety net to make sure that you kind of you really do have the answer, short of actually doing it a second time. Okay, 90. All right, we're on a roll now. Yeah, we're on a roll, man. Okay, an unmarked straight stick will be laid end to end over a measure of, just make sure we're live. Yeah, we are. Okay. An unmarked straight stick will be laid end to end over a distance of exactly 72 feet. So basically we're going to start here. And somehow we have a stick that I'm just going to end basically there. And I'm going to put dot, 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 because we're going to lay it on end to end many times. And then eventually we're going to get here, okay, which is equal to this thing here. And then the last same length of the stick. And finally, we're going to stop. So we're going to start here. And end here. Okay, so now they're telling us that that's 72 feet. Okay, they tell us now that the same stick, so whatever this length is here, let's call it L, that same stick is laid end to end as well again, and it ends up being 30 feet. Okay, so let me just change the color. Make believe I redrew this, and then there's a second run of it that's 30. Okay, I'm writing this as if both lengths are the same. They're not. I'm just basically modeling it instead of drawing this twice. That's really good. That's the worst 3 I ever saw in my life. Okay, and that would go out to there as well. Okay, so what is the length of the longest possible stick that can be used for both measurements? Okay, when you see something like this, on the surface it seems like it's impossible. How could we do that? The trick, the mathematical aspect of here is the same length stick laid end to end is 72, and the same length stick laid end to end is 30. So this is what is actually going to be the greatest common factor. Okay, what length between 72 and 30 can be used for both of them? Okay, and one key, at least that was slightly helpful in this problem, is it used longest. Okay, so what we need to do is actually just do the GCF of 72 and 30. Okay, that may leap out of you. It doesn't. We can actually just compute it then. So we have 30. And there's a few techniques to do this. I seem to favor the one I'm going to be using here, which you guys may not see. I don't know how often it's used in New York City classrooms, but it's the one I'm going to use. And I will show you in a second. So what you want to do on the left-hand side, that's a 2, is use small prime numbers. Wait a second. As divisors until we can't divide anymore. So basically, the smallest prime I can think of would be 2. So I'll put 2 here. 2 goes into 30 15 times. And 2 goes into 72 36 times. Okay, 2 does not go into 15 evenly, but 3 does. Does 3 go into 36? Yep, so 3 would be our next choice here. And I get 5 here. 3 times 5 is 15. And 3 goes into 36 12 times. Okay, I'm not left with anything that I can divide into both of them, so I'm done. Okay, and I basically have prime numbers, 2, 3, 5, and that. Okay, what I'm going to do is look at the ones on the left-hand side only, which is the 2 and the 3, and I'm going to multiply them. Okay, once I do that, I get 6. So that would be G. And think it through. If I laid a 6-foot thing end to end, could I get to 72? Yeah, and 12 times. And if I did that same thing, could I get to 30? Yep, up to 5 times. So 6 turns out to be the longest stick where that commonality is possible. And the commonality is the greatest common factor. Okay? So it kind of all jives for you there. My voice is going. I was yelling earlier, so I'm surprised I can even talk. Okay, let's try 91. And how much time are we using so far? Let's see here. We went about 34 minutes, so let's do a few more problems. Let's see what the time is once we get through this page. There are 6 different cookies on a plate. Aiden will choose 2 to pack in his lunch. How many different pairs of 2 cookies can he choose? So that's kind of pairs of 2, right? Because you get a pairs. Normally a pair is 2, but you could have groups of 3, if you will. So how can he choose from the 6? So it seems to me he has 2 positions to fill in. The first slot in his lunch bag for one of the cookies, and a second slot for the other. So he has 6 choices out of all the cookies, because there's 6 of them to use for the first choice. Once he uses the cookie, he only has 5 possibilities left for the second cookie. Okay, that means he has 30 possibilities that he could use to do this. Okay, that implies the answer is C. It's not. Because if he chooses cookie A, whoops, give this 1 second to catch up. If he chooses cookie A for the first and cookie B, We chooses cookie A and cookie B. Then that is the same as choosing B and A. So therefore, what we need to do is divide this by 2. Okay, because it said how many different, not how many total, how many different ways. So because they're the same, the answer here would be B. So this is, again, is another throwaway question that if you know how to do this, should take you about 15 seconds at most, and it'll gain you time for questions that turn out to be harder. All right? And by the way, in the previous choice, you could have also listed out the combinations and ended up realizing that it would be a time waster and an annoyance, and it could be slightly error prone to actually list them out, but that is also one way to do it. Just write out all the combinations, and it actually may leap out at you that A and B is the same as B and A, and then be left with that. But on the flip side, writing so many out, it may not hit you in the face that that's what's happening. All right, so just keep that in the back of your mind for those kind of problems. So during a presentation, Dion can create 5 slides in 20 minutes. So normally when I see something like this, a flag already goes up that either I need to know the number that this person does in an hour, okay, and I don't know yet, but I'm just going to explore that with you guys. So in an hour would be 60, right? We don't know if that's the question yet, but this would be equal to 15/60. If that's what the question eventually asks us. I don't know. Just throwing this out there because this question can have a lot of tweaks. Okay, so times 3 times 3. You could also do the cross product and get 5 times 60 equals 20x and then solve. Or we could just do it in the spot, okay? Kira can create 3 slides in 20 minutes. Oh, sorry, in 10 minutes. Let's get rid of that. Okay, so that would be equal to x over 60. And again, we can do 3 times 60 equals 10x. Or we could just look at the 2 fractions here and see that the denominator is a multiple of 6. Okay, that's the new one. This actually wrote the 6 backwards. That's 60, believe it or not. So it's times 6, so the top would be 18. And then it asks, what is the total number of slides the 2 of them can create in an hour? Since I already converted to 60ths, and again, I didn't have to have done that. If I did that and that wasn't the question, I would definitely have been wasting time. So I only did this for exposition purposes, and it turned out that that's what they're asking, okay? So what it means is now what we need to do is, well, first of all, let's make sure those are actually correct. Times 3 times 3 times 6 times 6, yep. What is the total number? So we're going to have to add the 15 and the 18 from here, and we get 33, right? Which would be G. So again, this would be a no-brainer problem for the most part. Okay, so 92 would be G. Okay, number lines come up enough on the SHSAT. So let's see what the heck is going on with this one. There's always a little tweak to it. So it looks like the tweak in this one, without even looking at the words, is that we have fractions and decimals. So at some point, we need to decide whether to convert something or not. Okay. So it says, I'm just going to look at it. Point L, point N on the same line. L is 4 and 5/16. It does not give us a value for N. It's probably going to ask us to compute that and or use it in some manner and or do something else. All right, so let's get to the words. On the lumbar line above, cool, Ln equals equal to 1/8. Okay, so it's saying the length of this here is 1/8. So that means if we wanted to compute N, we don't know if we need to, but let's again just explore that. 1/8 is 2/16. Because we're trying to get the thing at the bottom here right. Most likely it's going to ask us to subtract this or something. Okay. If that's 2/16, then N must be 4 and 7/16. All right. So we computed that. We don't know if we need to, so let's see what's going on. On the number line above, that's that point M not shown is located between L and there. So let's just assume M is somewhere near the middle of it. So M is right there, let's say. Okay. Which value below is a possible value for M? All right. So we need to determine now from the fractions where the other kind of number would be. So let me just shift this down slightly. So it really means we need to convert the decimals into fractions. So we can divide 16 into 5. There's 2 digits on each of the answer choices. So I'm going to go 3 or 4 digits in the actual solution. So this one turns out to be not a hard question, but just an annoying question, especially if you make a computation error. So it really comes down to your arithmetic. So I'm going to put the 2 zeros here and here to match the two digits in each answer. And I'm going to add at least another one, just to make sure in case there's a rounding issue. Okay. So that means this point goes straight up. 16 goes into 5. It doesn't. 16 goes into 50. Again, 16 times 3, as we saw in the other example, is 48. Okay, we're left with 2. All right. 16 goes into 20 once. So we're left with 4. 16 times 2 is 32. I'm going to add one more 0 because I expect that's going to be a 5. 32, we're going to get 8 here. Right, 16 times 5 is 8, okay? All right, so that's the 1. And we basically need to do the same thing again for the 7. So we're going to do 16 into 7. And we're going to kind of do the same thing. We're going to add at least 2 zeros because all the answer choices are zeros. and put at least 3 of them. Those are all zeros, believe it or not. So 16 goes into 7, it doesn't. Let's bring the decimal point up. 16 goes into 70. Let's see, 16 times 4 is 64. So we have 4. And we got 6 left over, is that right? 64, yes, 6 left over. So 16 goes into 60. Can't go 4 anymore, so it has to go 3. So we get 48. And then what do we get left over? 12. So 16 goes into 120. Let's see, 5 is 90. 8, is that 8? Something like 8. 80. Nope, it's not 8, it's 7. Okay, and I'm not sure if I should compute anymore because that's already above answer choice number G. So let me just reread the question to make sure I'm still on sync with it. So on the number line above, Ln is equal to 1/8. Point M not shown is located between L and N. Good. What value below is possible for M? Okay. So now we have the 2 endpoints. So all we have to rule out is the 2 that don't matter. So if 4 5/16 meant it was 4.3125, then A is over here. Okay. B is 431. So B is almost right up to L. B is just before it. Okay. C is 435. So C is definitely after L. But is it before N? Well, yeah. That's 437. So C is good. And D is over here. D is past N. So C would be our answer. And give me 1 second. I'm actually going to check this one because, yeah, the answer C. Because I don't want to have made a mistake. So now that all that said, you guys should know all your fractions. You should know a half, a third, a fourth, a fifth, a sixth, a seventh, an eighth, a ninth, a 10th, 11th, a 12th. Okay? Know all the way up to 1 over 112. Okay? So you should have known that 1/8 was 0.125. So that means once you computed what L was, okay, you could have just added it once you understood the context of the problem. So add the 0.3125. And I didn't compute that last digit up here, but we're going to get it now. Because when we add the 2 of these, we're going to get 5 plus 0 is 5. 5 plus 2 is 7. 2 plus 1 is 3. And 3 plus 1 is 4. So if you notice, this turns out to being the same number that was up here, and we could have done it a lot faster. Okay, if you knew that 1/8 just goes into 0.125. Okay, so you could have saved a few seconds by using that strategy. This is a busy enough problem. Normally, when there's a conversion that has to happen, there's often an optimal way, but sometimes you don't know till the end of the problem. After you solved it, you're like, oh, I could have done it faster that way. All right, so that's kind of the quandary with this, if you will. Just stick it in the back of your mind. If nothing else, this is a second way to show to get the value that you need, the point 4375. Okay, to note that C is the only one within the boundary between the two of those numbers. All right, so you have a second way to actually compute these numbers, which you always want. Okay, 94 is a classic. It looks like an interest problem, but let me see here. Johan leased a car for 3 years. And by the way, they would do this often in many problems. If you notice, they put the word instead of the number. He paid a one-time fee of $1,800, $1,000, and an additional $300 per month for the full, again, 3 years as a word. At the end of the 3 years as a word, what is the total amount he paid for leasing his car? All right, so what we really need to do is, if it's $300 per month, we need to do 300 times 36, because 12 months a year for 3 years. So we can go through the normal gymnastics, or we can know that 36 times 3 is 90 plus 18 is 108. So we get 108. And I've only done 36 times 3 right now. I need to add these two zeros back onto the end of it. So we get 10,800. Don't just stop. You haven't solved the problem, so the answer is not G. You need to take this one-time fee and add that to that, okay? So in other words, the answer is H. Many of you start solving word problems and you know all the math, and then you get so engrossed and caught up and your mind's so distracted that you forget what the actual question was. So a good rule of thumb is when you do a word problem, go back and reread the whole thing to make sure that the answer you got makes sense for the question that they asked you. Yeah, okay? That you include each part. If you notice, I have stuff I underlined. I circled the 1,000. I underlined the 300 per month. I underlined each 3. That's clues for you to go back. You yourself should be underlining this. And when you go back, you yourself should be using your own flags to detect where you are or aren't. Okay? All right, 94. So we said we can do another page. How we do it on time here? Okay, it's 3:30. Give me 1 second. We're going 55 minutes, I think. Let me see here. 54 minutes almost. All right, let's see what's on the next page. Let's see if there's still 20 questions left. Is that right? Yeah, there's still 20 questions left. Well, let me do one more, because there might be a doozy on this page or the next page that's going to slow up. So that means I'll try to do this in two additional parts, each 10 questions each. Okay. Okay. This one's pseudo complicated. So I'm going to skip that for now. I'm going to do 96. So a lot of you are just totally bent out of shape for 96. It says, what is m over n in terms of these? So let's write m over n. And then let's substitute it. Right? We already know m is w over x. And we know that n is y over z. Okay, some of you can even get as far as this problem as doing this, and then you don't know what to do. But remember, this form here Then I'm going to underline in the green this form here, this whole thing. I'm going to circle it in the green. We can write it in another form, because if I have A over B, if I have, let me rephrase it, if I have anything divided by a fraction, anything divided by a fraction, so that would be numerator over denominator, okay? This is the same as anything times the reciprocal of the fraction. So then we would take not n over d, but we would change the divide to multiply and do d over n. Okay, so there's a couple of numerators here. The original n in this green that I did here, this here, is the whole w over x. So what we want to do then is w over x divided by y over x. Wait, did I write that wrong? No, this should have been a z originally. Sorry, guys. Okay. The interesting thing about doing errors like I just did is that you should be able to keep track of your own mistakes. That just leaped out at me instantaneously because I was about to write y over x and I knew that there was not two x's in the problem. It's only one x. So this maps into times, so we're going to w over x times the reciprocal, so z over y. And when two fractions are besides each other and being multiplied, we could just combine all the numerator to be w times z over y, x times y, which would be g. That's 96 is g. Booyah. All right, guys. I may actually start another one of these up in about 5 minutes. Let's see how that goes. In the meantime, peace and love. Peace and love. Peace and love, like Ringo. Hopefully you're all right and this is helpful. Please like and subscribe. You guys can email me. I'm Greg at GregsTutoringNYC at gmail.com. Let me see here. I have that actually here. Let me just pop it up at the end here. Okay. Contact me for tutoring. Contact me for questions. I'm here for y'all. Okay. Peace.